Today, we're going to dive into a story about a single molecule that's inside every single one of us. And this molecule, well, it's both a life-saving hero and sometimes a critical weakness.
So, I want you to just think about this for a second. What if your body's best defense, the very system designed to protect you, also had a secret flaw that enemies could exploit? It sounds like something out of a movie, right? But that's exactly the story we're exploring today. All right, so let's meet our main character. Its full name is Intercellular Adhesion Molecule-1, but we can just call it ICAM-1. Now, what is it? Well, it's basically a protein that sits on the surface of your cells. Think of it like a traffic cop for your immune system, pointing your body's defenders exactly where they need to go. So first up, let's look at what ICAM-1 does on a normal day. You know, its day job. Which, by the way, is absolutely crucial for keeping you healthy.
You know, what's really fascinating is where you find ICAM-1. It's not just scattered around randomly. Nope. It's strategically placed at all these critical checkpoints in your body. We're talking about the inner walls of your blood vessels, on your immune cells themselves, and even lining your airways. It's basically the gatekeeper at all the most important borders.
Okay, so a really great way to picture this is to think of ICAM-1 as a sticky patch on the inside of your blood vessels. But it's a smart sticky patch, right? It's not sticky to just anything, only to the right cells and only at the right time.
So here's how that whole process works. Imagine you've got an infection somewhere. Your white blood cells, the leukocytes, are just rushing through your bloodstream. The first thing they do, they grab onto these ICAM-1 sticky patches to slow down. That's step one. Then, step two, they adhere. They come to a complete stop, sticking right to the wall where they're needed. And finally, step three, they migrate. They actually squeeze right through the vessel wall to get to the fight. It's just this incredibly precise and honestly heroic process.
But this is where our story takes a bit of a dark turn. What happens when our hero tries to help, maybe a little too much?
So imagine a really serious infection. We're talking about a major battle going on inside your body. In response, your system basically screams for reinforcements. And how does it do that? It tells the blood vessels to produce way more of these ICAM-1 sticky patches. And these are the actual chemical messengers, the distress signals that give that order. You've got these cytokines like TNF-alpha and interleukins-1 and 6. They just flood the area, and their message is simple. It's urgent. We need more ICAM-1, and we need it now. And the response? Well, it is dramatic. As you can see here, in normal, healthy tissue, you've got this low, steady level of ICAM-1 just doing its thing. But look at what happens in inflamed tissue. That level just skyrockets. The whole system just gets kicked into overdrive. And this over-recruitment, this flood of immune cells, it can have some really devastating consequences. We see this in severe conditions like pneumonia, ARDS, or sepsis. So many immune cells are called in to fight that they actually start causing friendly fire, damaging our own healthy tissue, especially in the lungs. So the very response that's meant to save us can tragically end up contributing to respiratory failure.
But the problem isn't just about our body overreacting. Sometimes an outside invader learns how to exploit our hero's good nature to hijack the system.
A not-invader, well, it's one we're all unfortunately familiar with. The human rhinovirus. Yep, the main cause of the common cold. This little virus is incredibly successful because it has literally evolved to take advantage of ICAM-1.
And this really gets to the heart of the problem, doesn't it? You've got these two faces of ICAM-1. Its intended role is to be a docking port, right? A safe harbor for our own immune cells. But the rhinovirus figured out how to use that exact same docking port as a doorway, a way to break right into our healthy cells.
The mechanism is just brutally efficient. As it says here, the virus binds to ICAM-1, enters the cell, replicates, and spreads infection. It's a perfect hijacking. It turns our own defensive structure into its personal key to the city.
Okay, so this brings us to the central dilemma of our story. This is the great challenge that this one tiny molecule presents to us.
So if there's one thing to take away from all this, it's this. ICAM-1 is a perfect example of a double-edged sword in our own biology. It is absolutely essential for fighting off infections. We need it. But that very same essential function creates a vulnerability that can be turned against us, either by our own immune system going into overdrive or by a clever virus that's learned how to exploit it. And that leaves us with this huge, profound question for the future of medicine. You have a hero and the vulnerability, all wrapped up in a single molecule. The challenge is,
How can medicine possibly target the bad stuff without accidentally harming the good stuff that we depend on every single day? It's a tough one,